Hey, welcome back. So quite often, our analytics will encompass multiple business processes, which usually means multiple data tables in our data model. These data tables are typically very granular and cannot be related to each other in a one-to-many fashion. So how can we combine them in a single pivot table, which is kind of the point of this whole Power Pivot thing? The answer is to find one or more tables that are connected to both of these data tables and are on the one side of the relationship with both tables. So as an example of another process in our online surf shop business, we have a data set for service calls, which is basically calls that are taken by our business's call centers. Now there's no direct correlation between calls taken at a call center and orders placed on our website, but there are some attributes these things have in common. For example, the same customer with the same customer ID might make a call to our call center and might also place an order on our website. Similarly, a service call may be in regards to a product, and that same product might be something that is sold on our website. So while there's no obvious direct relationship between these two separate processes, using the Excel data model, we'll still be able to combine data from these processes into a single pivot table. Let's see how. So our first step will be to just import this service calls CSV file into Excel with Power Query and then land it in our data model. So let's do that. So as usual, I'll go to Data, Get Data, From File, from Text CSV, and then I'll select our service calls file and hit Import. And then just as a best practice, I'll hit Transform Data. And it looks like headers were promoted, and just scrolling across the fields in this data set, it looks like the data types that Power Query chose are appropriate. So I'll go ahead and click Close and Load, and then Close and Load To. And as usual, I'll only create a connection to the file, and of course I'll add it to the data model. And now that our service calls file has loaded, let's click our Power Pivot tab on the ribbon and hit Manage to go to our Power Pivot window. And then we'll check out the diagram view. And since things are getting a little bit crowded in our data model, we'll zoom out. And now we see our service calls table kind of orphaned off to the right, not connected to any other tables. So the first step, as usual, will be to identify what relationships this table has to other tables in our model, so we can then incorporate fields from this table into our pivot tables. So first of all, we see that there's a customer ID field, and we know we have a customers table in our data model that also has a customer ID field. So that seems like a natural relationship. Now our customers table has one record per customer ID, while you would expect that a single customer might have placed many service calls. So that looks like a natural one-to-many relationship. So I'll move my service calls table down a little bit so it's aligned with my order details table, and then I will just click my customer ID field in the customers table and drag across to the customer ID field in my service calls table. And just like that, our one-to-many relationship was formed. Now it looks like we might also have a potential relationship with the products table based on the product ID field in the service calls table. And this also makes sense as a one-to-many relationship. Of the products we sell, you figure that there have probably been multiple service calls about each one, yet our products table only has one row per product. So again, a natural one-to-many relationship. So I'll click the product ID field in the products table, and then just drag down to the product ID field in our service calls table. And there we go. Another one-to-many relationship automatically detected by the Excel data model. Now our model is getting a little bit messy looking at this point, which is pretty typical once you start adding a lot of tables. So I think I'm going to reposition our service calls and order details tables just to make the relationships they have to other tables in the model more clear. Okay, so at least that's a little bit better. Now the next step, of course, is to try to combine metrics based on values in our service calls table with metrics based on fields from our other data tables in a single pivot table. That's really what we've been driving towards this entire section of the course. So if you want to meaningfully combine metrics from two data tables in the same pivot table, the key thing to remember is this. All filters applied to the pivot must come from a table or tables that are related to both data tables in a one-to-many fashion, either directly or via a chain of one-to-many relationships. So for example, if we want to do a count of service calls and a count of line items in our customer orders in a single pivot table, and then filter that by some field in one of our lookups, that lookup has to have a one-to-many relationship with both of these tables, either directly or indirectly through one of these chains of one-to-many relationships. So for example, we should be able to use fields from our products table as filters against both our service calls and order details data, because the products table has a one-to-many relationship with both of those tables. However, if we want to combine data from our orders table with data from our service calls table in a single pivot, we wouldn't be able to use the products table as a filter, because it only has the one-to-many relationship with the service calls table. But that's enough theory for now. Let's do a quick demo to see these principles in action. So going back to Excel, I'll insert another pivot table. And for my first pivot, I'll do a count of order details, which is basically the line items in all of our customer orders, and a count of service calls, broken out by product. So first, I'll drag sales order detail ID from my order details table down to the values section, and then change the way it's summarized to count. And next I'll navigate down to my service calls table, and then drag call ID down to my values area, and then do a count on that. Alright, so far so good. We have an accurate count of the records in both of those tables, which is just essentially the count of the transactions in both of those business processes. So now to break that out by product, I'll roll back up to our products table, and then drag name down to rows. So far so good. It looks like our name breakout is working just fine. And again, going back to our data model, that's because our products table has this one-to-many relationship with the service calls table, and then it also has this one-to-many relationship with our order details table. But what would happen if I want to do a count of customer orders from our orders table here, also broken out by product in the same pivot table? So let's go back to Excel and find out. So in my field list, I'll go back to the orders table, and now I'll drag in sales order ID and do a count on that. Yuck. This is the same thing we saw in the last video, and for the same reason. So because there's no one-to-many relationship, either directly or indirectly, between the products table and the orders table, we're not able to filter on that count of sales order ID from the orders table by products. So you just end up with the grand total, basically the number of rows in the table, for every single row in our pivot. So for this particular breakout by product, we won't be able to include any metrics based on our orders table. Now it's a bit different, on the other hand, if I want to break our pivot out by something like, say, region. So if I remove rows from the name section, and then add region, now it looks like we're getting accurate breakouts for all three of our metrics. So to fully understand why, let's again go back to our data model. And the key table to understanding this relationship is our customers table. Now our customers table has a one-to-many relationship with our service calls table, and it also has a one-to-many relationship with our orders table, which in turn has a one-to-many relationship with our order details table. So customers is qualified, so to speak, to filter all three of those tables. And then because regions is uphill, so to speak, or to the left in the geography of our particular data model, of the states table, which is to the left of the customers table, regions is able to apply a filter to customers. So in short, customers can filter all three of our data tables, and then states can filter customers, and regions can filter states. Hence, we're able to use regions to filter all of the data tables in our model. Now, I know it may seem like I've really been belaboring this principle of why some tables can be used as filters, but others can't. But if you can just internalize this one thing, you're well on your way to being an effective data modeler in Microsoft Excel. Okay, so just knowing how to use Excel's data model to analyze multiple data sets in a single pivot is a huge deal. And compared to what we were previously able to do in Excel, it's actually a pretty revolutionary ability. But one limitation of old-fashioned pivot tables we haven't yet overcome is the lack of flexibility when it comes to the calculations we can perform in the values area. If we want to do anything more involved than a simple count or sum, we need to involve calculated fields, which have lots of limitations in their own right. Well, Power Excel has a solution for this too. An entirely new programming language called DAX. That's DAX, and it stands for Data Analysis Expressions, which gives us incredible power to inject custom calculations in our pivot tables. And don't worry if learning a new programming language sounds a little intimidating. DAX is based on the syntax of standard Excel formulas and functions, so if you're familiar with those, picking it up should be a snap. That's all coming up in the next section. I'll see you then.